minutes, but we want you to really have the appreciation that these first three pillars are really the secret to this AI pillar. That you really got to have an incredibly robust local terrestrial network and data centers to really kind of anticipate where the puck is going, to really kind of skate to where that puck is going to be in the future with your digital infrastructure and what AI is going to need, and therefore what's really going to differentiate your region. So I want to talk just for 10 minutes and try to put it into perspective. You know, we're all using large language models right now, and it's just one little aspect of the field of AI research. There is a ton of research outside of large language models, deep meaning, deep learning and machine learning and all kinds of things. So we're all getting used to this chat GPT, which is just one of about a dozen large language models, and they really are quite simple, and people tell me this slide really helps them understand it. It's really just a predictor of the next word. And so look at this little simple formula: cat, sat, on a, then what's the next word? Well, if you only have like 5 words in your database that the large language model uses, it picks and ranks according to the percentage of what is the most logical choice, and it gives you that. But what it's doing is it has a database of 500,000 words or tokens, and so it really is sophisticated enough to help you with scientific papers and to help you learn, and it's just fascinating, and I'm sure everyone in this room is using that. And so we're kind of all fixated on this, and it's helping us in our work worlds and our hobbies and interests, but it really is a word predictor on steroids. So I don't know if that's helpful to you to understand it, but where are we headed with this? So this is just a glimpse into the future. Here we are at stage 1, predictive AI, and we're kind of made this leap over to generative AI. And so we're in this chat GTB era, and I want to tell you, chat is becoming like the generic, like Kleenex is a brand, but also a category, because there are all these other large language models that work. But it really creates realistic images, or almost realistic, and voice clones and all the things that we're experiencing. But we're about the end of this era, and we're already starting to see the signs of agentic AI, and that's going to be the next 5 years or so. And that's where AI is going to become more like a digital employee that thinks and acts on their own, and that they've got the intelligence built in to do that, to provide that added value, hopefully with some guardrails, but really be able to execute on tasks from models that we create, and really be transformative in where we're headed in just about every aspect of life. And so this is where we're headed to this next stage 3. And I could go on to stage 4, 5, and 6, and it gets really spooky out there. But just right now where we are and where we're going to be in the next couple of years is this the agentic AI. And so write that down and just look that up and start to understand this. It really is going to be our best friend in helping us become even more efficient, but not having to be there to make it work like we do right now with generative AI. And so here's a really simple way to think about this. Right now we're at teaching and learning, and we're getting ready to go to acting and doing. That's where we're headed. And so agentic AI and real-time connectivity is going to transform everything. I'm just going to give you one quick example. In healthcare, right now, physician practices and doctors and hospitals are using AI, drafting notes, scanning images, and doing a read on a X-ray, and looking at patterns and trying to really predict what kind of disease state it might be, a diagnosis or something like that, responding to patients. But where we're going to head is this ubiquitous nature of AI behind the scenes in the entire healthcare system, monitoring patient signals, prioritizing alerts, scheduling interventions, coordinating with pharmacies, drafting care plans, doing all this. And the studies that are coming out now are showing that AI is starting to outperform diagnoses by looking at the inputs that doctors look at. So just phenomenal. It's like having a 140 IQ doctor with you at every step of the way, but being ubiquitous in how it all works seamlessly together and making their own decisions on your care. It sounds scary, but It's the future, and it's where we're going. So it's going to go from answering to managing to acting. That's where we're headed in all of this. So here's a really low-cost diagram of how it works in a market. And this is just a typical generic market. And my friends like Marcellus Nixon and network people in the room can probably do a better job explaining this. But you have terrestrial networks in every single market and carriers, and they are like overlays, like spider webs, I like to think about. And then we heard this morning about Internet Exchange Points, or IXPs, and they kind of connect all those overlays together. So you really can look at a market and look at how many people are connected. And that's important, parenthetically, for the content providers like a Netflix or a Google or a Microsoft Office. Y'all all have those accounts. Well, if you're in a market like Richmond at 1.3 or Hampton Roads at 1.7, and you got an exchange and all these networks are sort of carrier neutral, then those content providers look at you and go, oh my gosh, I don't want to pay for John to watch his Netflix movie going to Ashburn or Atlanta and back for that whole movie. I'm just going to take all of that content and go to Scott Brown and say, Scott, here, put it in your data center. I'm going to send you some servers with all those movies. And have at it, John, and it's going to be less expensive for Netflix. Do I have that kind of right, Scott? Okay. So having an internet exchange and having these networks is really great. But then here comes the super duper role of data centers. You got to store this someplace. And everybody's so caught up on hyperscalers. We love hyperscalers. But they're all other kind of sizes. Scott, how big is your data center? 10,000 square feet. And data centers are going to even get smaller in some cases. But you got to have them to store local data centers so this all can work. And they're called edge data centers, close to the end user. So if you have these terrestrial networks and you're just so lucky that you got an internet exchange and you got these edge data centers and you got a reliable power source like we heard this morning, you are sitting pretty, because that's where AI is headed. It's going to be this generative AI that is working all the time behind the scenes, and it's got to talk to that data center. And you might say you're driving an autonomous vehicle, because they're coming, taxis first, but they're already in a lot of towns. Or you're running your healthcare system, and maybe there's an emergency, and the ambulance comes, and it's talking to a doctor, and the doctor's prescribing things and operating through the technician right there. All of this stuff benefits from a robust local terrestrial network and edge data centers. That's what makes generative AI really work in real time. That's what we have here, is that kind of ecosystem, and that's the whole conceit of what we're trying to keep building. So we can run AI better than anybody else. And if you happen to have some subsea cables, all the better, because then you can tap into so many other data sets. But that be local, that local idea is going to get more and more important as AI gets more and more sophisticated. So, Marcellus, did I do okay? All right. So that's basically it. And there's some really great first movers and shakers that are making stuff happen here. And one of them is from ODU.